Hello everyone, so today in this video we are going to discuss the question same count 1 which is asked in polynomial round 2022 div.1 plus div.2. In this question we are actually given n binary arrays of length m. We can see that here we are given 3 binary arrays each having a length of 4. And in one operation what we can do is we can choose any two arrays and any position of the two arrays. That position in the two arrays should be same and we can swap the elements at that position, and we want to find the minimum number of operations such that the number of ones in all the arrays become equal. If we won't be able to get the number of ones in all the arrays equal, we will return -1. So let's understand with the help of the test cases which we are given to us. So first let's see the first test case. In the first test case we can see that we are given 1 1 1 0 0 0 1 0 and 1 0 0 1. What we can see that here we are having 3 ones, here we are having 1 1, and here we are having 2 ones. So the total number of ones in this whole grid are 6 ones, 3 plus 2 plus 1. And if we want to divide, if we want the number of ones in all the rows to be equal, what we can see is that all the rows if contains same equal number of ones, and we have total number of 6 ones, so 6 divided by number of rows, that total number of ones divided by total number of rows gives the number of ones in each row. So we can see that the number of ones which should be in each row should be equal to 2. But we can see that here only one row has two ones, but the first row has greater than 2 ones and the second row has less than 2 ones. So what we will do is, let's say we will remove this one and make it 0. That let's say we will choose this array and this array. We will make this one as 0 and this 0 as 1. That is, we have swapped both of them. Now we can see that this array now contains 2 number of ones. This array also contains 2 number of ones. This is 1, and this array also contains 2 number of ones. So the minimum number of operations, or I can say the minimum number of swaps which we had done is 1. So answer in this case is, we can see 1. Answer is 1, and we are given the second array and the first array. We had also chosen the second array and the first array, and we have swapped first element. Here I had swapped the second element. We can also do by the swapping of first element. We can do in any of the way. Now let's understand the second example. In the second example we are given 1 0 0 0 1 1 0 0 1 0 0 0. Here the number of ones in the first row are 1, in the second row are 2, in the third row are 1, and then in the fourth row are 0. So number of ones in total are 4. And in each row we want the same number of ones. So total number of ones divided by the number of ones in each, the number of rows is 4. So we can say that we want number of ones to be 1 in each row. That we can see here this row contains only 1 ones, here this row also contains only 1 ones, here this row contains less than 1 ones, and here this row contains greater than 1 ones. I want only 1 in each row, but here this contains 2, here this contains 0. So what I can easily do is, I will take up this index, this array and this array. I will convert this 1 to 0 and this 0 to 1. That is, I have swapped both of them to get my answer. Therefore it also requires only one operation. So answer is 1. Only one operation it requires. So answer is 1. Here we have chosen fourth array and the second array. Here also you can see fourth and the second. They swap the second index, that is this one and this one. I swapped the third index. And the last case we can see that the number of ones total are 1, which dividing 2, which we won't be able to divide by 2. So answer here is -1. So let's see how we will solve this question. So let's take the first. So let's take a bigger example in which the minimum number of operations are greater than 1. Let's I will try to find such example in which the number of operations required are greater than 1. So it will be easy for you to understand how we will go further with it. So let's take the second example. And we can see that the answer to this question is minimum 3 number of operations are required in order to get the same number of ones in all the rows. So now this is my answer. Okay, so let's see whether we will be able to get the answer or not. So what we can see that first the first step is we will first get the number of ones in each row. We will see that the here number of ones in first row is 2, the number of ones in second row is 1, the number of ones in third row is 1, the number of ones in fourth row is 3, the number of ones in fifth row is actually 1, the number of ones in sixth row is 3. I will also mark the rows 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. In the 7th row the number of ones are 2, in the 8th row the number of ones are 2, in the 9th row the number of ones are 2, and in the 10th row the number of ones are 3. So let's sum up the total number of ones. 3 plus 2, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There are 20 ones and 20 ones, and there are total number of 10 rows. So we want 2 number of ones in each row. So first we will see that which rows contains exactly 2 ones. So we will see that this row contains exactly 2 ones. So we won't consider this row. This row also contains exactly 2 ones. So we also don't consider this row. Also don't consider this row, and also don't consider this row. We won't consider these 4 rows, as these 4 rows contains the number of ones which we want in each row. Now we will consider other rows. Let's first understand how we will analyze each row. We can suppose I go to second row. While go to second row, I will ask to myself whether this row contains the number of ones which I required. Whether this row contains the number of ones less than the number of ones which are required or greater than the number of ones which are required. I can see that the number of ones which are required are actually 2. And this row contains the number of ones is equal to 1. So I can say that this row wants one more one. So I can say that this row is actually an acceptor. Similarly, this row also contains only 1 and we want 2 ones. So this row is also an acceptor. So until other rows which is this also an acceptor. Now we will go to the row which is having value 3. This row contains 3 ones and we want that every row should contain 2 ones. So it means that this row contains more ones than which we want. It means this row can act as donor. Then this row can donate 1. Similarly for this row, similarly for this row. So these are our acceptors, these are our donors. So what I will do is I will traverse row column wise. That is, first I will go to first column, then I will go to second column, then I will go to third column, then I will go to fourth column. So on I will traverse column wise. Suppose I go to first column. In the first column, I will traverse from first to end. First row to 10th row. I will go to first row. I will ask whether the number of ones in it are. It says the number of ones are 2, and I don't have to count the number of ones again. I will just make an array which stores the count of number of ones in each section, each row. So I will go to the first row and I will ask to myself how many ones it contains. So it contains 2 ones, and I also want 2 ones. So okay, this is fine. So I don't think of this row. Then I go to second row. In second row in the first column, I am only traversing the first column of every row. I will ask the number of ones it contains. It says the number of ones are 1 and I want a total of 2 ones. It means this row wants 1 and we can see that this row wants 1 and here 0 is present. If this row wants 1 and 0 is present, it means what we can do is, suppose in the future, in the same column which I am traversing, that is the first column, I got a row number in which the number of ones which are present are greater, and apart from that the number of ones which are present are greater, as well as that this contains 1, that is this column contains 1. What I'm trying to say is, as we go ahead you will be able to understand what I'm trying to say is, so let's say I make 2 arrays. Apart from this I make 2 arrays. In the first array what I will say is, in the first array I will say what are acceptors and what are my donor. Initially both are empty. When I reached the second row and the first column, I will say that okay, this is my donor, this is my acceptor actually, and it contains 0. As this is my acceptor and it contains 0, matlab in future there is a possibility that I can replace this 0 with a 1 of acceptor. Carefully listen what I am trying to say. I am saying that in the same column, in the future, this acceptor contains 0. I can replace this acceptor 0 with a donor 1 of same column in the future. I can replace this acceptor 0 with a donor 1 in same column in the future. So I can say that the acceptor is 1 and acceptor is 1. Now I am going to third row and the first column. I can say that here the value is 1. Here it is also an acceptor, but it can't accept. Why it can't accept? It can't accept because it don't have 0. Because if it would have 0, then we can swap its 0 and donor 1. But now we can't swap its 0 and donor 1s. And we know that it is useless to make any other swap. That is, it is useless if we swap its 0 and its 1 and acceptor 1 and donor 1. So what I will say is, it is useless to see third column, third row right now. So until we will traverse, we will see that here all are 0. It means any of the acceptors does not contain 1. So this 0, the second row, then the second row and the first column 0 can't be converted to 1. So from the acceptor let me remove this 1. Now I will move to the second row, second column. Now I will move to the second column. Now I can see that here the 1 which is the now second row and the first, we can traverse from second row and the second column. We can see that the second row and the second column contains 0. And we can also see that this is the acceptor 1. Acceptor 1 contains 0. So I will mark that the row, you can see in the array of acceptor I have written 2. It means the 2 is the acceptor 1 and it contains 0. Then I will traverse further. I will see that 3 is also an acceptor 1 and it also contains 0. So in the acceptor array I will put 3. This is actually an array, don't consider it as a stack. Now I will reach 4. I can say that the fourth array is a donor 1 and it contains 1. So I will put 4 in donor 1 as it contains 1. As it contains 1, therefore there is a possibility of swap. And as we move further, we can see that there are no ones in this donor, so we will reject out. Then at this instance, what we observe? I have 2 acceptors which are ready to accept. As they contain 0, and I have done 1 donor which is ready to donate as it contains 1. So I will take the minimum of both. Minimum of both means it contains 2 values, it contains 1 value. So minimum of both is 1. So I will say okay, that the second row, here you can see the second row and the fourth row, would have a swap at which column number? At second column number, because I am currently at second column. So here I can also see the solution which is provided by them, that we have chosen the second column. We have chosen the second column, and we have chosen the rows as fourth row and second row. We have chosen the row as fourth row and second row and the second column. Similarly, we can go to each column and do the same, and this is the approach. Let's go into the code section. First, I had made a count once, that it will count the total number of ones. If the total number of ones is divisible by n, that is divisible by the number of rows, then the answer is yes, else the answer is no, else the answer is -1. Apart from that, I have made total ones of I plus plus. What I have done is that total ones contain the number of ones in each row. If I want to know that the total number of ones in the 0th row, or I can say the 5th row, so I will say total ones of 0, total ones of 5. It will tell me the total number of ones in that row. And of course, after each swap, suppose I have made a swap in 4th row and the second row. So what I will do is, I will decrement this donor count by 1, and I will increment this acceptor count by 1 to get 2. So in the future we will be able to get to know that this won't now no longer be an acceptor, and this now won't longer be a donor. After that, we will say the number of ones in each section. It will be count of ones by n. Now this is the most important section. I am traversed from 0 to n. What I am doing is, I am going to each column. I am maintaining two vectors. One is extra and other is require. Extra, what does this mean? Extra means which are having extra number of ones, and require means which requires one, which wants one, that is which are begging for one. Then I am traversing the whole from 0 to n, that is the whole row, and asking if v of ij is 1, and if v of ij is 1 and that is the donor, so I am put it in extra. If v of ij is 0, and we can see that is the acceptor one, so I will put it in the required, that it requires 1. After that, I will take the minimum, that is val is the minimum of both extra and the required. Then similarly, I have done that extra of I plus 1. Why I made I plus 1? Because it is actually in question we have to do it in one based indexing. Then I decrement the size, that is I decrement the size of extra by 1 and increment the size of required by 1. And similarly, then I print out the answer. So this is the approach. If you like the approach, please like, share and